On paper, a battery factory is simple. You build a big building, you fill it with machines, and capacity appears. In reality, scale does not arrive just because square footage does. It arrives one production step, one trained worker, one delivered machine, and one grid connection at a time. If you open a map of planned and operating battery plants, two patterns stand out. One pattern is made of dense industrial clusters and supplier parks. These have been expanding continuously for more than a decade. The other pattern is made of a newer wave of very large plants. These are often tied to fresh policy incentives and complex joint ventures. News headlines often frame this as a race between countries. They ask who is winning and who is falling behind in the battery arms race.
Scaling battery
in this
production
episode,
requires optimizing
we will set the
complex
scoreboard
variables.
aside.
These diagrams help us visualize the
Instead,
impact.
we will look at how factories actually get built and ramped. We will outline what happens inside a plant
The
when
assembly
capacity
line
doubles.
moves continuously, illustrating the massive scale
We will
of modern
sketch two
battery
different
production
strategies for
and the
reaching
critical
scale
role of automation.
using anonymous visuals. We do this to avoid turning this into a branding exercise. We will trace the bottlenecks that both strategies run into, from grid connections and water to workforce and quality control. Then we will end with a checklist you can use whenever you see a chart of gigawatt hours by country or region. Every visual you see here is an AI-generated reenactment or conceptual diagram. It is not real footage of specific companies, plants, or regions. This episode is educational only, and not engineering. Investment, financial, policy, or geopolitical advice. With that in place, let us start on the factory floor, not with a headline. A modern battery plant is less like a single machine and more like a high-stakes relay race. It begins with mixing. Raw materials, lithium, nickel, cobalt, graphite arrive in bulk. They must be turned into precise slurries for coating electrodes. This is not just stirring a pot. It is chemistry at scale. The viscosity must be perfect. The mix must be homogeneous. Any contamination here ruins the cell weeks later. Next comes coating and drying.
Factories, the process is a linked
Thin
series
films
of
are coated
stations.
onto copper and
From raw
aluminum
materials-
foils. Then they pass through massive ovens. These ovens are hundreds of meters long. They consume enormous amounts of energy to evaporate the solvents. Once dried, the rolls are cut into precise shapes in a process called slitting. Then comes assembly. Cells are stacked or wound, filled with electrolyte, and sealed. This happens in a dry room. Humidity here is controlled to less than 1%. Even a breath of moisture can destroy the chemistry.
Visualize the flow. As module assembly increases,
Cells then
we see the
sit in
corresponding
formation
rise
ranks.
in overall capacity.
This is where they are
A
charged
look at
and
the
discharged
anatomy
under
of a
controlled
large-scale battery
conditions.
plant. The flow of materials from cells
This is the
to finished
awakening of the
packs.
battery. It
As
takes
the cells
time and
queue for
massive floor
assembly,
space.
The automated mechanism isolates and welds them into modules.
After formation, cells are sorted, grouped, and assembled into modules. Modules and control electronics are combined into packs. Packs are tested, labeled, wrapped, and shipped to automakers or storage projects. Each of these stations has its own throughput, uptime, and scrap rate. If one station falls behind, it creates a queue and starves the next station of work. Scale is not just how many packs leave the loading bay in a year, it is also how much buffer sits as work in progress, and how often a bottleneck moves from one step to another. When people talk about a 50 gigawatt-hour factory, they are
The
usually
smooth
talking
operation
about a
of the
capacity
conveyor
number on
system
paper.
highlights the synchronize.
The lived reality inside the plant is a series of ramps and debottlenecking projects. One way to build capacity at scale is to grow dense industrial clusters. In these clusters, many battery plants, material suppliers, and equipment makers sit close together. This is the strategy often seen in East Asia. Some factories are brand new, while others are retooled from previous industrial uses. Specialized contractors can move from one project to the next without traveling far. If a mixing machine breaks in Plant A, the technician is already down the street at Plant B. Local governments may concentrate infrastructure upgrades in these zones. High-voltage power lines and chemical pipelines are built once, serving multiple tenants. Because plants sit near each other, support services can be shared. Maintenance crews, calibration labs, and safety testing facilities replicate quickly. Small and mid-sized factories can be added over time as demand becomes clearer. In this pattern, scale looks less like a single giant building. It looks like a web of related sites. This creates a phenomenon called knowledge spillover. Workers learn best practices at one site and carry them
The
to the
scale
next.
of modern battery production relies on
If
dense
one plant
industrial
stalls,
clusters, optimizing
others in the cluster
logistics
can
from
keep
cell
expanding.
plants to module assembly.
On the other hand, clusters can concentrate risk. They can put massive, simultaneous loads on local grids and water systems. A power outage in the zone hits everyone. A labor shortage affects every employer. They can also create strong path dependence. It makes it harder for new regions to compete without building their own clusters from scratch. Another way to build capacity is to launch a wave of very large plants at once. This is the pattern currently unfolding across North America and parts of Europe. These mega projects often come with high visibility. They are driven by public incentives and joint ventures between automakers and battery specialists. Because the facilities are so large, they demand major upfront investment. Land must be acquired at a massive scale. Grid connections must be negotiated years in advance. Workforce training becomes a monumental task. You are not just hiring workers. You are building a workforce from zero in a region that may not know batteries. Suppliers may commit to building nearby plants to reduce logistics costs. But they often wait until the main plant is certain before breaking ground. Construction can take years. And ramping from the first cell to full design capacity can take more years after that. This introduces the J-curve of production. In the beginning, output is low and scrap rates are high. The factory burns money before it makes batteries. In this pattern, capacity growth looks lumpy.
The expansion
Charts
strategy
show
highlights
long
the
flat
challenge of
lines
managing
followed by
bottlenecks.
big upward
Here we
steps
see new
when
capacity
plants
ramping
finally
up,
ramp.
but constraints remain visible across the supply chain.
The upside is that each successful plant can move a region's capacity number significantly. A single site can supply hundreds of thousands of vehicles. The downside is that delays at a single site make the whole trajectory look worse. From the outside, mega plant announcements can sound like instant scale. From the inside, they feel like long sequences of gating tasks.
The strategy emphasizes massive scale. However,
Permits,
as these new gigafactories
foundations,
ramp up, managing the supply
structural
chain remains
steel,
the critical bottleneck.
machines delivered, lines tuned, teams trained. Regardless of strategy, both clusters and megaplants run into a similar set of constraints. The first is power.
As the prismatic cells move down the line,
Battery
the
factories
automated
draw
welding
large,
process is a key area
steady
for
amounts of
potential
electricity.
bottlenecks.
Connecting them to the grid can require new substations and transmission lines. Those ovens and dry rooms run 24/7. If the local grid is strained, upgrades must be paid for. The second constraint is equipment. Many factories compete for the same suppliers of coating lines and formation towers. These machines are specialized. Lead times can stretch to 18 or 24 months.
The rapid scale-up of battery production relies heavily
A
on
single
efficient
delayed
logistics
mixing machine
and a
can
skilled
hold back a whole
workforce,
production
both
block.
of which present ongoing challenges.
The third constraint is people. Operators and engineers must learn to run highly automated, sensitive processes. Workforce ramp is not just about headcount. It is about experience. A team that has never seen a coding defect won't know how to fix it quickly. The fourth constraint is quality. High scrap rates can quietly erase capacity on paper. Even if a factory pushes cells through the line, only a fraction may meet the standards. This is called yield. A 50% yield means half your energy and materials just went into the trash. When you compare regions, the differences show up in timing and risk. Cluster-heavy approaches show smoother capacity growth. Incremental additions smooth out the curve. Mega plant waves shift capacity in big jumps. But they carry execution risk on a massive scale. A single canceled
The
project can move
expansion
projections
reveals
for
key
an entire
constraints.
state.
As this new facility comes online, the grid
Mega
connections
plants
flagged
also
as the
face
next
steeper
major
learning curves
bottleneck
if
in
the local
process.
ecosystem is still forming. In practice, no country relies on a pure version of either
The
strategy.
control room monitors global capacity. As production
Regions with
scales,
established clusters
bottlenecks often
are
appear
building
first
new
at the
flagship
connection
plants.
points, as seen here.
Regions launching megaplants are frantically trying to grow supplier bases. So how can you read the next battery capacity chart with more context? First, look at whether the capacity number refers to operating plants or just announced projects. A press release is not a battery.
While often framed as a competition,
Second,
the global scale-up highlights
whether the
shared
map shows
challenges
one
in
big
securing
cluster,
raw materials and reliable
many
grid
scattered
connections.
sites, or a mix. Scattering reduces disaster risk, but increases logistics friction.
Monitoring the
Third,
global rollout, we
think
see
about
the
where the
impact of
bottlenecks
new
are most
capacity.
likely to appear.
However, this red symbol highlights a
Is it grid connections, equipment lead times, or workforce training? Fourth, pay attention to the time dimension. Does the chart assume every plant ramps smoothly to full capacity on day one? Or does it account for the J-curve and learning periods? Fifth, consider flexibility. Clusters can retool faster. Megaplants have large, fixed investments that make pivoting harder. When you look at the US and China through
As
this
the
lens,
site expands, the
question
capacity step
changes.
diagram illustrates the projected output over the
it
next
becomes
few
less
quarters.
about who is winning and more about how each system is set up to respond to shocks and policy shifts. Regions with deep supplier networks adapt differently than regions with newer, standalone giants. Both patterns bring strengths and vulnerabilities. As a viewer, you do not need to choose a side in a manufacturing context. You can focus on understanding the mechanisms
Scaling
that
up
turn
battery
land,
production involves navigating
machines,
complex constraints.
people,
As new capacity
and electricity into capacity centers. That understanding travels with you across industries and across headlines.
The transition from individual
Thank you for
cells
watching
to complete
and thinking
line
in systems.
requires precision welding, a critical bottleneck in the
If you want
scale-up
more episodes that
process.
turn viral comparisons into process maps, there are more on this channel. In the comments, tell me which bottleneck you think is
The
most
process versor
underestimated.
analysis shows how land, labor,
Power,
and logistics impact
equipment,
the speed of construction.
Workforce,
As capacity ramps
or
up,
quality.
the focus shifts to efficiency. These robotic
This episode is
systems are
educational
designed for
only
continuous
and not
operation.
engineering, investment, or policy advice. It is a lens on how factories scale, not a
The
verdict on
scale-up
any
of
country.
battery production relies heavily on optimizing
See you in the next one.
logistics chain.
Inside the Gigafactory, prismatic cells move rapidly through the line. The process verse dashboard tracks capacity and